Hello, in this lecture we will answer on two questions. The first question is to find out the diameter of this orange circle, and the second question is to find out the value of this angle theta. So we'll start with the first question. Here we have three semicircles. Inside the biggest semicircle we have two small semicircles and one circle. The diameter of this small semicircle is 10 units, therefore the radius is equal to 5 units. The diameter of this semicircle is equal to 20 units, therefore the radius is equal to 5 units. And the diameter of the biggest semicircle, this semicircle, is equals to 10 plus 20 is 30 units, and therefore the radius of the biggest semicircle is 15 units. And we define the diameter of this circle, the orange circle, as R, and the center of this circle is at point C. So I write it down. The diameter of this orange circle is equal to R. R is the radius of this orange circle. And the center of the orange circle is at point C. So R is the radius of the orange circle. Okay. So in the first step we will define the center of this small semicircle as point X. We will define the center of the biggest semicircle, this semicircle, as point Y, and we will define the center of this semicircle as point Z. We know that the center of the orange circle is at point C. In the next step, we join the centers of the semicircles with the center of the orange circle. So here, this is line segment XC, this will be line segment CY, and this will be line segment CZ. So the center of the orange circle is at point C. And in order to find out the lengths of line segments CX, CY, CZ, XY, and XZ, I will present to you a new rule. Actually, we have two types of tangency between two circles. The first type of tangency between two circles is the external lunge. When the two circles touching each other externally, then it is defined as external lunge or external tangency. those two circles are touching each other at this point. This is the point of tendency. We know that the center of the small circle is point M and the radius of the small circle is small r. The center of the big circle is at point O, and the radius of the big circle is capital R. So here the distance between the centers of those two circles is the length of line segment MO, and the length of line segment MO is equal to the sum of the lengths of their radii. That is to say, it is equal to capital R plus small r. So this is the first type of tendency between two circles, and we also have, that is the external lunge. We have also a second type of tendency between two circles, when the two circles touching each other internally, like in this drawing. It is defined as internal lunge, and those two circles are touching each other internally at this point. This is the point of tendency between those two circles, and in this case the distance between the centers of those two circles, that is to say the length of line segment MO, will be equal to the difference between the lengths of their radii. That is to say, it will be equal to capital R, that is the radius of the big circle, minus small r, that is the radius of the small circle. You can see it from the drawing that capital R minus small r will be equal to the length of MO, that is actually the distance between the centers of those two circles. So in conclusion, we have two types of tendency between two circles. Two circles can touch each other at one point in two different manners. There are two different types of touching between two circles at one point. The first type of touching between two circles is when they are touching each other externally. Then it is defined as external lunge, and the distance between their centers will be equal to the sum of the lengths of their radii. In this case, it will be equal to capital R plus small r. And the second type of tangency, or the second type of touching between two circles at one point, is defined as internal lunge, and it is when they are touching each other internally, like in this drawing. This is the point of tendency between the two circles, and in this case, the distance between their centers, that is to say the length of AO, will be equal to the difference between the lengths of the radii. In this case, it will be equal to capital R minus small r. Okay, so according to, and this is the internal lunge. So according to those two rules, we'll find out the value of the length of line segment CX. So what is the length of line segment CX? We know that the radius of the orange circle is equal to small r, and the center is at this point, point C. And the radius of this circle, small semicircle, is equal to 5 units. And the center is at point X. Cx actually is the distance between the center of the orange circle and the center of the small semicircle. Those two circles and semicircle have an external knot between them at this point, that is to say they are touching each other externally at this point. Therefore, the distance between their centers will be equal to the sum of the lengths of their radii. That is to say, the radius of the orange circle is equal to r, and the radius of the small semicircle is equal to 5. So in conclusion, the distance between the centers will be equal to the sum of the lengths of the radii, that is to say it will be equal to r plus 5. I repeat again, Cx equals to r plus 5. Okay, Cx is equal to r plus 5. And what is the length of line segment Cy? Here Cy, again, C is the center of the orange circle, Y is the center of the biggest semicircle, this semicircle. And the orange circle and the biggest semicircle have an internal length between them at this point. That is to say they are touching each other internally at this point. This is the point of tendency. And whenever two circles have an external length between them, then the distance between their centers will be equal to the difference between the lengths of their radii. That is to say, it will be equal to the radius of the biggest semicircle, that is 15 units, minus the radius of the orange circle, that is small r. In conclusion, we found out that Cy, that is the distance between the center of the orange circle and the center of the biggest semicircle, is equal to 15 minus r. Okay? In the next step, we'll find out the length of CZ. Again, C is the center of the orange circle. Z is the center of this semicircle. That is, radius is equal to 10 units. The radius of the orange circle is equal to small r. Those two circle and semicircle have an external length between them at this point. That is to say they are touching each other externally in this point. And whenever you have two circles that are touching each other externally, that is the external length, then the distance between their centers will be equal to the sum of the lengths of their radii. That is to say it will be equal to the radius of this semicircle, that is 10 units, plus the radius of the orange circle, that is small r. So in conclusion, we found out that Cz is equal to 10 plus r, 10 plus small r. And what is the length of line segment xy? Here x is the center of the smallest semicircle and y is the center of the biggest semicircle. Those two semicircles have an internal length between them at point A, that is to say they are touching each other internally at point A. Therefore, the distance between their centers will be equal to the difference between the lengths of their radii. And the length of the radius of the biggest semicircle is 15, and the length of the radius of the smallest semicircle is 5. That is to say, the distance between their radii, but the distance between their centers xy will be equal to 15 minus 5, that is 10. So we found out that xy equals to 10 units. Here, xy equals to 10 units. And we'll find out the length of line segment xz. What is the length of xz? Again, x is the center of the smallest semicircle, this semicircle, and y and z is the center of this semicircle. Those two semicircles have an external length between them at point P. That is to say they are touching each other externally at point P. And whenever you have two circles that are touching each other externally, you have the external length, then the distance between the centers of the two circles will be equal to the sum of the lengths of their radii. That is to say, it will be equal to the radius of the biggest semicircle, that is 15 units. No, it is actually, we are talking about xz. xz, so it is the radius, those two semicircles have an external length between them at point P, and therefore the distance between their centers will be equal to the sum of the lengths of their radii. That is to say, it will be equal to the radius of this semicircle, that is equal to 10 units, plus the radius of this small semicircle, that is equal to 5 units. So in conclusion, we found out that xz equals to 10 plus 5, that is 15 units. Okay, xz is equal to 15 units. Okay, so actually found out all the lengths of the line segments in this drawing. In the next step, I will present to you a new rule, a new law, that is the law of cosines, and we will implement the law of cosines in this drawing. So what is the law of cosines? First of all, the law of cosines is true in any triangle. The law of cosines, so you can use it in any triangle. What is the law of cosines? So actually, if we have this triangle, that could be any triangle, triangle ABC, this is triangle ABC. We know that side AB of triangle ABC equals to A units in its length, side BC equals to B units in its length, and side AC equals to C units in its length. And the angle between side AB and side BC is angle theta. Then, according to the law of cosines, C squared will be equal to A squared plus B squared minus 2 times A times B times cosine theta. I repeat again, according to the law of cosines, in any triangle, C squared will be equal to A squared plus B squared minus 2 times A times B times cosine theta. Okay, so we will implement the law of cosines in our triangle. It will be triangle XCY, so I will copy triangle XCY in a new page, and we will implement the law of cosines in this triangle, triangle XCY. Okay, so here we will have triangle XCY. Actually, we have already found out that Cx is equal to R plus 5. We have already found out that xy equals to 10 units, and we have already found out that Cy is equal to 15 minus R. Okay. Of course, we know that this is angle theta. So according to the law of cosines in triangle XCY, cy, we will get that cy squared, this will be equation number 1, cy squared will be equal to xc squared plus xy squared minus 2 times xc times xy times cosine theta. So here we will substitute in equation number 1 cy by 15 minus r, xc by r plus 5 and xy by 10. We do it now and we get that according to equation number 1 cy is equal to 15 minus r. So cy squared will be equal to 15 minus r squared, and it is equal to xc. xc is r plus 5, so xc squared will be equal to r plus 5 squared plus xy squared. xy is equal to 10, so xy squared is 10 squared, 10 squared is 100, minus 2 times xc is r plus 5 times xy is 10 times cosine theta. Okay, we'll open the brackets on both sides of equation number 1 and we'll get that according to equation number 1 15 minus r squared is equal to 15 squared, that is 225, plus r squared minus 2 times 15r is minus 30r, that equals to r plus 5 squared. R plus 5 squared is equal to r squared plus 5 squared, that is 25, plus 10r plus 100 minus 2 times 10 is minus 20 times r plus 5 times cosine theta. Okay. Here we have r squared on both sides of equation number 1, so r squared will get cancelled. And we will subtract 10r from this equation, equation number 1. And we get here minus 40r. We'll subtract 100 from equation number 1. So here we will have, actually we'll subtract 125 from equation number 1. So here we will have 225 minus 125 is 100. So according to equation number 1, 100 minus 40r is equal to minus 20 r plus 5 times cosine theta. Here we will divide equation number 1 by minus 20 r plus 5 and we will get that according to equation number 1 cosine theta is equal to 100 minus 40r over minus 20 times r minus, plus 5 So here we will divide both the numerator and the denominator by minus 20, and we get that here minus 40r over minus 20 is 2r, 100 over minus 20 is minus 5, that equals to minus 20 over minus 20 is 1, so here we will have r plus 5. So in conclusion, we found out that according to equation number 1, cosine theta is equal to 2r minus 5 over r plus 5. Okay, I'll repeat again. Found out that according to equation number 1, cosine theta equals to 2r minus 5 over r plus 5. In the next step, we will implement the law of cosines in triangle XCZ. So I will copy triangle XCZ in this new page, and we will implement the law of cosines in triangle XCZ. We have already found out that xc or cx equals to r plus 5. We have already found out that xz is equal to 15, and we have already found out that cz is equal to 10 plus r. So actually, according to the law of cosines, we will get that cz square, here it is actually angle theta, so cz square according to equation number 2 equals to cx square plus xz square minus 2 times cx times xz times cosine theta, of course. So here we will substitute cz, xz, and cz, xz, and cx by the values that we found for them, and we'll get that according to equation number 2, cz square is 10 plus r square, that equals to cx square. Cx is r plus 5, so cx square is r plus 5 square. Plus xz square. Xz is 15, so xz square is 15 square. 15 square is 225. Minus 2 times r plus 5 times xz, that is 15 times cosine theta. Okay. Here we'll open the brackets on both sides of equation number 2, and we get that according to equation number 2, 10 plus r squared is equal to 10 squared, that is 100, plus r squared plus 20 times r, that is equal to r plus 5 squared. R squared is r plus 5 squared, it is equal to r squared plus 5 squared, that is 25, plus 10 times r plus 225 minus 2 times 15 is minus 30 times r plus 5 times cosine theta. Here we have r squared on both sides of the equation. Number 2, so r squared will get cancelled. Here we have 225 plus 25 is 250. Plus 10r minus 30 times r plus 5 times cosine theta, that equals to 100 plus 20r. Here we subtract 250 from this equation, equation number 2, and we get that 100 minus 250 is minus 150. We will subtract also 10r from this equation. Again, we subtract 10r, so 20r minus 10r is 10r. So, in conclusion, we found out that minus 150 plus 10r is equal to minus 30 times r plus 5 times cosine theta. Here we will divide the equation number 2 by minus 30 times r plus 5, and we will get that according to equation number 2, cosine theta is equal to 10r minus 150 over minus 50 times r plus 5. So here we will divide the equation number 2 by minus 10, or we will divide both sides of equation of this side of equation number 2, move the numerator, the denominator of this side of equation number 2 by minus 10, and we'll get that according to equation number 2, cosine theta is equal to minus 150 over minus 10 is 15. Then r over minus 10 is minus r. That is equal to minus 30 over minus 3 is 3 times r plus 5. So in the next step we will create equation number 3 that states that cosine theta according to equation number 1 must be equal to cosine theta according to equation number 2. So equation number 3 states that cosine theta according to equation number 1, that is actually 2r minus 5 over r plus 5, must be equal to cosine theta according to equation number 2, that is actually equal to 15 minus r over 3 times r plus 5. Here we will multiply this equation by r plus 5. And we'll get that 2r minus 5 is equal to 15 minus r over 3. Here we will multiply equation number 3 by 3, and we get that according to equation number 3, 3 times 2r minus 5 is equal to 15 minus r. We'll open the brackets on this side of equation number 3, and we'll get that 3 times 2r is 6r, 3 times minus 5 is minus 15, that is equal to 15 minus r. Here we will add r to this equation, equation number 3, and then we'll add also 15. So we get that 7r is equal to 30. We divide equation number 3 by 7. And we get that the radius of the orange circle is equal to 30 over 7. And the diameter of the orange circle, that is equal to 2 times the radius, it will be equal to 2 times 30 over 7, that is actually 60 times over 7 units, or in terms of numbers, it equals to 8.5714 units. I'll repeat again, the diameter of the orange circle is equal to either 60 over 7 units, or in terms of numbers, it equals to 8.5714 units. Okay, so we finished with the first question. The next step I will present to you the second question of this lecture. So here we have a quarter circle, and inside this quarter circle we have a square ABCO, and we also know that this angle MAB is equal to 90 degrees, and also angle BQC is equal to theta, and we want to find out the size of this angle theta. In order to find out the size of angle theta, we will make a construction. Actually, we will extend line segment MA by a straight line, and we will also extend line segment QO by a straight line until they intersect with each other. Okay? and we'll define the intersection point of the extended MA and the extended QO as point N. In the next step, we will create from the quarter circle a semicircle. So created a semicircle from the quarter circle. Inside this semicircle that we created, we have the peripheral angle QMN. And the side of angle QMN is equal to 90 degrees. The side of the peripheral angle QMN is equal to 90 degrees according to what is given us in the question. And we have rule number 1. Actually, according to rule number 1, any peripheral angle that is equal to 90 degrees, any peripheral angle that is equal to 90 degrees must rest on the diameter. I will read again rule number 1. According to rule number 1, any peripheral angle that is equal to 90 degrees must rest on the diameter. And because of the fact that the peripheral angle NMQ is equal to 90 degrees, therefore according to rule number 1, it must rest on the diameter. And this peripheral angle that is equal to 90 degrees, that is to say peripheral angle NMQ rests on QN. Therefore, according to rule number 1, QN is the diameter of the semicircle. QN is the diameter of the semicircle according to rule number 1. Okay? And the diameter of the semicircle is equal to 2 times the radius, so because of the fact that this is a quarter circle, it means that QO must be equal to the radius of the quarter circle. So we define the radius of the quarter circle as capital R, so it will be equal to capital R, and therefore the diameter will be equal, is twice as large as the radius of the circle. Therefore the diameter that is actually equals to QN must be equal to 2 times the radius, that is actually 2 times capital R. And here NO, for Darwin you can see that NO is equal to QN minus QO. QN minus QO is equal to NO. QN is equal to 2R. QO is equal to R. That is to say, NO is equal to 2R minus R, that is R. So we found out that NO is equal to the R, that is that NO equals to R, that is the radius of the semicircle and also of the quarter circle. And we will focus on the right triangle NMQ. Actually, in triangle NMQ, in the right triangle NMQ, the right triangle NMQ, the sum of its angles must be equal to 180 degrees. So if we define the missing angle QNM as x, then x plus this angle that is equal to 90 degrees plus this angle that is equal to theta, in total the sum of those three angles must be equal to 180 degrees, according to the rule that the sum of the angles in any triangle is equal to 180 degrees. Here we will subtract 90 degrees from this equation and we will get that that x plus theta is equal to 180 degrees minus 90 degrees. It is 90 degrees. We will subtract theta from this equation and we will get that angle x is equal to 90 degrees minus theta. So we found out that the value of the size of the missing angle x, is 90 degrees minus theta. So we can substitute angle x by 90 degrees minus theta. We'll do it now and we'll get that this angle is equal to 90 degrees minus theta. So we write here that it is equal to 90 degrees minus theta. We also know that all the angles inside a square are right angles. So all the angles inside square A, B, C, O must be equal to 90 degrees. So we can write here that those angles are right angles. That is to say they are equal to 90 degrees. Okay. All the angles in square ABCO are right angles. We have already found out that NQ is the diameter of the semicircle according to rule number 1. Actually, NQ is the diameter of the semicircle. It is absolutely a straight line. NQ is a diameter, must be a straight line. NQ is a straight line. And we have rule number 2 that I will not write down, but you should remember rule number 2 that states that the sum of the angles on one side of a straight line is equal to 180 degrees. That is to say, the sum of the angles on one side of the straight line NQ must be equal to 180 degrees. So if we focus on the upper side, this side of the straight line NQ, then the sum of the angles at point O and the upper side of the straight line NQ at point O, the sum of the angles must be equal to 180 degrees according to rule number 2. So which angles we have at the upper side of NQ at point O? We have here this angle that is a right angle is equal to 90 degrees. We also have this angle that is actually angle AON. In total, the sum of those two angles must be equal to 180 degrees according to rule number 2. I repeat again. And up at the upper side of the straight line NQ at point O, the sum of the angles must be equal to 180 degrees, that is to say 90 degrees plus the size of angle AON. In total, they must be equal to 180 degrees. We'll subtract 90 degrees from this equation, and we get that angle AON is equal to 180 degrees minus 90 degrees. It is 90 degrees. So we actually found out that this angle, it is a right angle, it is equal to 90 degrees. Okay. Likewise, if we focus on the upper side of the straight line NQ at point C, then the sum of the angles at the upper side at the straight line NQ at this point C must be equal to 180 degrees. So which angles we have at the upper side of NQ at point C? We have this angle is equal to 90 degrees plus this angle that is angle BCQ. In total, the sum of those two angles must be equal to 180 degrees according to rule number 2. I repeat again, in the upper side of the straight line NQ at point C, the sum of the angles must be equal to 180 degrees, so 90 degrees plus the size of angle BCQ, in total they must be equal to 180 degrees according to rule number 2. We'll subtract 90 degrees from this equation, and we'll get that angle BCQ is equal to 180 degrees minus 90 degrees, it is 90 degrees. So we found out that this angle is a right angle, it is equal to 90 degrees. So we'll continue to focus on the right triangle BCQ. On the right triangle BCQ, the sum of the angles must be equal to 180 degrees. We define the missing angle CBQ as X. So angle X plus this angle that equals to 90 degrees plus this angle that is equal to theta, that is the angle that we are looking for. In total, the sum of those two angles must be equal to 180 degrees according to the rule that the sum of the angles in any triangle is equal to 180 degrees. Here we'll subtract 90 degrees from this equation, and we'll get that x plus theta is equal to 180 degrees minus 90 degrees, it is 90 degrees. Here we'll subtract x from this, we'll subtract theta from this equation, and we get that angle x is equal to 90 degrees minus theta. So we substitute angle x by 90 degrees minus theta. In the next step, we will focus on the right triangle AON. On the right triangle, triangle AON, the sum of the angles must be equal to 180 degrees. Again, in the right triangle, triangle AON, the sum of the angles must be equal to 180 degrees. We will define the missing angle AON as Y. So actually angle Y, the missing angle, plus this angle that is equal to 90 degrees minus theta, plus this angle that is equal to 90 degrees. In total, the sum of those three angles must be equal to 180 degrees, according to the rule that the sum of the angles in any triangle is equal to 180 degrees. Here, 90 degrees plus 90 degrees is 180 degrees, so we have 180 degrees on both sides of the equation, so 180 degrees will get cancelled. And we found out that y minus theta is equal to 0. We will add theta to this equation and we get that angle y is equal to theta. So the missing angle is equal to theta, so we substitute angle y by theta. Actually, we found out that all the angles inside triangle AON are equal to all the angles inside triangle BCQ. Why? Because both those two triangles have one right angle, both those two triangles have angle theta, and both those two triangles have angle that is equal to 90 degrees minus 2 theta. Therefore, the angles of those two triangles are equal to each other, and any two triangles that have all the angles that are equal to each other, they are similar to each other. So we can write down that the right triangle, triangle AON, is similar. This is the sign of similar. The right triangle, triangle AON, is similar to the right triangle, triangle BCQ, according to angle similarity rule. Okay, all the triangles, all the angles of triangle AON corresponding are equal to all the angles of triangle BCQ. Therefore, those two triangles are similar to each other according to angle similarity rule. And from the fact that those two triangles are similar to each other, we will conclude that the following relationship exists between their sides. We will conclude that CQ over AO is equal to BC over NO. Okay, I'll repeat again. Because of the fact that triangle AON is similar to triangle BCQ, we'll conclude that CQ over AO equals to BC over NO. This will be equation number 1. What is the value of CQ? It is very easy to see from the drawing that CQ is equal to OQ minus OC. That is to say, CQ is equal to OQ, that is capital R, minus OC. And we will define side OC of square ABCO as A. Therefore, all the other side will be also equal to A. So actually, we found out that CQ equals to OQ minus OC. OQ is capital R, OC is A. So in conclusion, we found out that CQ equals to capital R minus A. Therefore, we can substitute CQ in equation number 1 by R minus A. We'll do it now, and we will get that CQ is R minus A over AO. What is the value of AO? The value of side AO is also equals to A units, and it equals to BC. BC is equal to A units over NO. NO, you can see from the drawing that line segment NO is equal to capital R, the radius of the semicircle. Here we will divide this expression to two parts, and we'll get that R minus A over A is equal to R over A minus A over A. Minus A over A is minus 1. That is equal to R A over R. Okay? Here we'll focus on the right triangle, triangle AON. In the right triangle, triangle AON, you can see here that tangent theta is equal to R over A. We found out that R over A is equal to tangent theta. That is to say, we can substitute R over A in equation number 1 by tangent theta. We'll do it now, and we'll get that R over A, that is tangent theta minus 1, is equal to A over R. A over R is equal to 1 over R over A. Okay, now we can substitute R over A in this equation, equation number 1, by tangent theta. We'll do it now, and we'll get that according to equation number 1, tangent theta is tangent theta minus 1 is equal to 1 over R over A is tangent theta. Okay, so in conclusion, we found out that according to equation number 1, tangent theta minus 1 equals to 1 over tangent theta. Here we will multiply equation number 1 by tangent theta, and we will get that according to equation number 1, tangent theta times tangent theta is tangent square theta, and tangent theta times minus 1 is minus tangent theta, and it equals to 1, yes? So we'll subtract 1 from this equation. Minus 1 equals to 0. We got here a quadratic equation, and the variable in this quadratic equation that we are looking for is tangent theta. Actually, the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Here A, B, and C are the coefficients of this quadratic equation, and x is the variable that we are looking for. X is the variable that we are looking for, and we will find out the value of x according to the following special formula. X is actually equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, the coefficient a is equal to 1, the coefficient b is equal to minus 1, and the coefficient c is equal also to minus 1, and the variable that we are looking for, that is to say x equals to tangent theta. So we will put the data inside the equation for x, and we will find out the value of the values of tangent theta. So according to this solution to the quadratic equation x, we get that x is equal to tangent theta, so tangent theta is equal to minus b, b equals to minus 1. Minus b is minus minus 1. Minus minus 1 is 1, plus minus square root of b squared. b equals to minus 1, so b squared is minus 1 squared. Minus 1 squared is 1, plus minus 4 times a is 1, times c is minus 1, over 2a, 2 times a that is 1 is 2. So in conclusion, we found out that tangent theta is equal to 1 plus minus square root of minus 4 times minus 1 is 4, and 4 plus 1 is 5 over 2. So here we will have two solutions that are possible for tangent theta. The first solution for tangent theta is the tangent theta is equal to 1 plus square root of 5 over 2, and the second solution for tangent theta is the tangent theta is equal to 1 minus square root of 5 over 2. And this solution is a negative solution, it is less than 0, and this is a positive solution. And here in the drawing we have this angle. Actually, this angle is inside triangle AMQ, and inside triangle AMQ we know that this angle equals to 90 degrees. This is the biggest angle in triangle AMQ. And because of the fact that angle NMQ is equal to 90 degrees, it means that this angle must be less than 90 degrees. Okay, anyway, 90 degrees minus theta, it is less than 90 degrees from one side, but it must be a positive number. From one side it is less than 90 degrees, but from the other side, for 100%, it must be a positive number. Okay, actually all the angles inside a triangle must be positive numbers. So we can write down that this angle that is equal to 90 degrees minus theta, it is positive. So angle 90 degrees minus theta is a positive angle, that is to say it's greater than 0. So we'll add theta to this equation and we'll get that theta is less than 90 degrees from one side, but theta must be a positive angle from the other side. So we found out that the range of angle theta is from 0 to 90 degrees. And whenever the angle is from 0 to 90 degrees, in this range of angles, the function tangents theta, is positive. It is greater than 0. In the range of angles from 0 to 90 degrees, tangent theta is a positive, while according to the second solution, tangent theta is a negative. It is a contradiction. So this solution is incorrect solution. We will cancel this solution and we left only with the solution that tangent theta equals to 1 plus square root of 5 over 2. And we want to find out the value of tangent theta itself. So we will operate the inverse function of tangents on the result. So the inverse function of tangents, the inverse function of tangents, we will operate it on the result, that is 1 plus square root of 5 over 2. So the opposite sides, when we operate the opposite function of function tangents on the result, we will get the value of tangents, the value of theta itself. So the inverse function of tangents, when we will operate it on the result, that is 1 plus square root of 5 over 2, we will get the value of theta, that is actually equals to 58 over 28 degrees. So we found out that angle theta is equal to 58.28 degrees. I will repeat again. The value of the angle that we are looking for, the value of this angle theta, is equal to 58.28 degrees. Okay? So in the next step, I will summarize the lecture. So actually, we wanted to find out the value of this angle theta. We have here a quarter circle. Inside this quarter circle, we have square ABCO. We know that angle AMQ is equal to 90 degrees. Angle BQO, this angle is equal to theta, and we want to find out the value of the size of angle theta. In order to find out the size of angle theta, we made a construction. We extended line segment MA by a straight line, and we extended line segment QO by a straight line until they intersect with each other, and we define the intersection point of those two line segments as point N. Again, the intersection point between those two line segments is defined as N. Then we completed the quarter circle to a semicircle. So we have here this semicircle, and inside this semicircle we have the peripheral angle QMN that is equal to 90 degrees. It is given as the question. So inside a semicircle we have peripheral angle that is equal to 90 degrees. Then I presented to you rule number 1. According to rule number 1, any peripheral angle that is equal to 90 degrees must rest on the diameter. And again, according to rule number 1, any peripheral angle that is equal to 90 degrees must rest on the diameter. So here, because of the fact that the peripheral angle M and MQ is equal to 90 degrees, therefore according to rule number 1, it must rest on the diameter. And this angle, peripheral angle NMQ, rests on NQ. That is to say, we will conclude from it that NQ is the diameter, because this angle that is a right angle must rest on the diameter. And it rests on NQ, therefore the peripheral angle NMQ rests on the diameter, that is NQ, therefore NQ is the diameter of the semicircle. So according to rule number 1, NQ is the diameter of the semicircle. Okay? And the diameter is twice as long as the radius. That is to say, the diameter is equal to 2 times the radius, because the radius of this semicircle is defined as R. That is to say, because of the fact that this is a quarter circle, then QO must be equal to the radius of this quarter circle. That is to say, it must be equal to R. Okay? But we know that NQ is equal to 2R. QO equal to R. So NO will be equal to NQ minus QO. Again, NO will be equal to QN minus QO. QN is equal to 2R, QO equals to R. So in conclusion, we found out that NO equals to 2R minus R. That is to say, ON is equal to R. So we found out that this line segment ON is equal to R, and also OQ is equal to R. Then we focus on the right triangle NMQ. In this right triangle, the sum of the angles must be equal to 180 degrees. Which angles we have in this right triangle NMQ? This is the missing angle. We defined it as angle X. So angle X plus 90 degrees plus angle theta, in total they must be equal to 180 degrees. I repeat again, the right triangle NMQ, the sum of the angles must be equal to 180 degrees. This is to say, angle X, the missing angle, plus 90 degrees plus angle theta. In total they must be equal to 180 degrees. Here we subtracted 90 degrees from this equation, and we found out that x plus theta is equal to 180 degrees minus 90 degrees. It is 90 degrees. We subtracted theta from this equation and found out that angle x is equal to 90 degrees minus theta. So the missing angle here is equal to 90 degrees minus theta. Then we know that all the angles inside a square are right angles. So in square ABCO, all its angles must be equal to 90 degrees, all the 4 angles. And we have already found out that NQ is the diameter of the semicircle. NQ is the diameter of the semicircle. It is absolutely a straight line. NQ is a straight line because it is the diameter of the semicircle. And we have rule number 2. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. Okay? So if we focus on the upper side of the straight line NQ at point O, then according to rule number 2, the sum of the angles on the upper side of NQ at point O must be equal to 180 degrees. Which angles we have on the upper side of NQ at point O? We have here 90 degrees plus the size of angle AON. In total, the sum of those two angles must be equal to 180 degrees. Again, the right angle that is 90 degrees, that is one of four angles of square ABCO, plus the missing angle that is angle AON. In total, the sum of those two angles must be equal to 180 degrees, according to rule number 2, that the sum of the angles on one side of a straight line is equal to 180 degrees. We subtracted 90 degrees from this equation and found out that angle AON is equal to 90 degrees. So here, the missing angle is the right angle. It equals to 90 degrees. Likewise, if we focus on the upper side of the straight line NQ at point C, then according to rule number 2, the sum of the angles on the upper side of NQ at point C must be equal to 180 degrees. So which angles we have at the upper side of NQ at point C? We have here 90 degrees plus the size of angle BCQ. In total, the sum of those two angles must be equal to 180 degrees. Okay? Here at point C, one angle that is equal to 90 degrees plus the size of angle BCQ. In total, they must be equal to 180 degrees according to rule number 2. We subtracted 90 degrees from this equation, and we got the missing angle, angle BCQ, is equal to 90 degrees. So this is a right angle. Okay, so we continue to focus on the right triangle, triangle BCQ. In this right triangle, the sum of the angles must be equal to 180 degrees. So this is the missing angle that we will define as angle X plus 90 degrees plus theta. In total, the sum of those three angles must be equal to 180 degrees, according to the rule that the sum of the angles in any triangle is equal to 180 degrees. Again, the missing angle that is angle X plus the right angle plus angle theta. In total, the sum of those three angles must be equal to 180 degrees. We subtracted 90 degrees from this equation, and we got that angle X plus theta is equal to 180 degrees minus 90 degrees. It is 90 degrees. We subtract the theta from this equation, and we got that X, the missing angle, is equal to 90 degrees minus theta. So here, this angle is equal to 90 degrees minus theta. In the next step, we focused on the right triangle, triangle AON. In the right triangle, triangle AON, the sum of its angles must be equal to 180 degrees. So this is the missing angle that we define as angle Y, plus 90 degrees plus 90 degrees minus theta. In total, the sum of those three angles must be equal to 180 degrees. I repeat again, the missing angle here, that is this angle Y, plus the angle that is equal to 90 degrees minus 2 theta plus the right angle. In total, the sum of those three angles must be equal to 180 degrees in the right triangle, triangle AON. Here we have 90 degrees plus 90 degrees is 180 degrees. So we have 180 degrees in this side of the equation, and we have 180 degrees on the other side of the equation. So 180 degrees will get cancelled, and we left only with y minus theta that is equal to 0. We added theta to this equation, and we found out that angle y is equal to theta. So the missing angle here is equal to theta. So we actually found out that all the angles of the right triangle, triangle AON are corresponding equal to all the angles of the right triangle, triangle BCQ. Therefore, you can see here that both those two triangles have angle theta, both those two triangles have angle that is equal to 90 degrees minus theta, and both those two triangles have right angle that is equal to 90 degrees. Therefore, those two triangles have all three angles that are equal to each other. Therefore, those two triangles will be similar to each other according to angle similarity rule. The right triangle, triangle AON is similar to the right triangle, triangle BCQ according to angle similarity rule. And from the fact that those two triangles are similar to each other, we will conclude that CQ we conclude that CQ over AO is equal to BC over AO. Again, CQ over AO is equal to BC over ON. CQ over AO equals to BC over ON. Okay, here CQ over AO equals to BC over ON. What is the value of CQ? Here CQ is equal to OQ minus OC. CQ is equal to OQ minus OC. OQ is the radius of the semicircle, that is to say it equals to capital R. OC is equal to A. So in conclusion we found out that CQ is equal to R minus A. So we can substitute CQ in equation number 1 by R minus A. So CQ that is equal to R minus A over OA. OA equals to A. So here we have R minus A over A. It is equal to BC. BC is also equal to A over ON. ON is equal to R. So in conclusion, we found out that according to equation number 1, R minus A over A is equal to A over R. We divided this expression to two expressions, to two parts. If R minus A over A equals to R minus A over A. Minus A over A is minus 1. That is equal to A over R. But in the right triangle, triangle AON, this right triangle, we know that tangent theta is equal to R over A. In the right triangle, triangle AON, we know that tangent theta is equal to R over A. So we can substitute R over A by tangent theta in equation number 1. We did it and we got that R over A it is equal to tangent theta minus 1. It is equal to A over R. But A over R is equal to 1 over R over A. So we can substitute now R over A by tangent theta. We did it and we got that tangent theta minus 1 equals to 1 over R over A is tangent theta. So in conclusion, according to equation number 1, we got that tangent theta minus 1 is equal to 1 over tangent theta. We multiplied equation number 1 by tangent theta, and we got that according to equation number 1, tangent theta times tangent theta is tangent square theta minus tangent theta times minus 1 is minus tangent theta, and it equals to 1. We subtracted 1 from equation number 1 and we got that tangent theta square minus tangent theta minus 1 equals to 0. So we got here a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c is equal to 0. A, b and c, this general quadratic equation, are the coefficients of this general quadratic equation, and x is the variable that we are looking for, and we will find out the value of x according to a special formula for x. X is actually equal to minus b plus minus b squared minus 4 times ac over 2a. In our specific quadratic equation, this quadratic equation, the coefficient a is equal to 1, the coefficient b is equal to minus 1, the coefficient c is also equal to minus 1. So here, the variable that we are looking for is tangent theta. So we'll find out the value of tangent theta by this equation. Here x equals to tangent theta. So we get that, we put the data inside this equation, we will get that tangent theta is equal to minus b. B is equal to minus 1, so minus b is minus 1, minus 1 is 1, plus minus b squared minus 4 times AC, b is minus 1, so b squared is minus 1 squared is 1, minus 4 times a is 1, so it is minus 4 times 1, times c is also minus 1, so inside the square we have inside the root we have 1 minus 4 times minus 1 is plus 4, so 4 plus 1 is 5. So inside the root we have 5. So in conclusion, we found out that tangent theta equals to 1 plus minus square root of 5 over 2. So here we have two solutions that are possible for tangent theta. The first solution is tangent theta equals to 1 plus square root of 5 over 2, while the second solution is tangent theta that is equal to 1 minus square root of 5 over 2, that is a negative solution. We focused on the negative solution. Here we know that this is angle inside a right triangle. We have the right triangle NMQ. This is a right triangle because this angle is equal to 90 degrees. Inside this right triangle, we have this angle that is equal to 90 degrees minus theta. And actually, all the angles inside the right triangle must be positive angles. Therefore, this angle that is equal to 90 degrees minus theta must be a positive, that is to say 90 degrees minus theta is a positive, it is greater than 0. We added theta to this inequality and we got that theta is less than 90 degrees from one side, but actually angle theta, it is also a positive angle. Okay, angle theta is a positive angle, that is to say it is greater than 0 but less than 90 degrees. And in this range of angles that are greater than 0 and less than 90 degrees, tangent theta is a positive. But according to the solution, tangent theta is negative. It is a contradiction. Therefore, this solution is incorrect solution. And we will focus on the solution, only on the solution on the positive solution, that tangent theta is equal to 1 plus square root of 5 over 2. And in order to find out the value of theta itself, we will operate the inverse function, the opposite function of tangents, in order to find out the value of theta itself. So when we operated the inverse function of tangents on the result, that is 1 plus square root of 5 over 2, we got that angle theta itself is equal to 58.28 degrees. So in conclusion, the answer to the question is that the value of tangent theta is equal to 58.28 degrees. Okay? I'll repeat again. The value of this angle theta is equal to 58.28 degrees. Okay? Thank you very much.